Assalamu alaikum. This is Sada Noreen Reza and my ID is 181011092. Our project is mainly focused on an irrigation system sensing the temperature, humidity, water level and soil moisture. Temperature and humidity sensor will help us to predict raining possibility. When the water level goes down and soil level increases, the water pump will be disabled and tank pump will turn on. Again, when the water level increases, the tank pump will be off. The moisture level increases will result in an increase in the humidity and the water pump will be on. In the soil moisture sensor, VCC pin supplies power for the sensor. We have connected the ground of the sensor to the ground pin of the power supply. To regulate the value, we have used a potentiometer here connected to the test pin. A0 gives us analog signal which can't be directly connected to the Arduino without ADC, so we have used an inductor to create the connection and used a capacitor in the ground. We have used two pumps, one for watering and another one for filling the tank. These LED lights will be blink when current flows. Basically, this works as an indicator light when the water and tank pump runs. In the water level sensor, we have connected a potentiometer with the test pit to regulate the values of the water level to the ground. This is our temperature and humidity sensor and this is our serial port. All the sensors are connected to the Arduino and giving data to it and run the driver to regulate which one to start and which one to stop. The LCD monitor will set to receive the outputs of the sensor via Arduino, show the reading in percentage and save it. Thank you.
Hello, I'm Mohammad Samin Iftija and I'll be explaining the Arduino code of our project. So first of all, we have included some necessary library files to communicate with these sensors over here, and also we have defined some pins of the Arduino board to communicate with the rest of the system. And after that, we have used this setup function to set up a connection between the boards and the sensors and also the LCD display. And we have set a baud rate of 9600 bits per second for the serial connections. And after that, inside this loop function, we have called all of the rest of the functions, because this loop functions acts as the main function of the entire code. So eventually all of the methods that we need to execute will be called inside this loop function. So we have called some methods to get readings from these sensors, as you can see. And we've also called this condition method, and this method is used to check for certain conditions. And if those conditions have been met, we will give certain outputs using those predefined pins of the Arduino board, and also show some status messages using these SMS and LCD functions that we have used to show messages on the terminal and also the LCD displays. And also this SST_S function is used to get temperature and humidity values from the SST21 sensor that we have used in the project. So all of these methods will be called each time the loop function is called. So and the loop function will be called at a 50 millisecond interval. So I have already compiled the code and converted the code into binary, and if I run the project, the code should give us some outputs. As you can see, the LCD display is showing the outputs, and also if I turn on the virtual terminal, we should be able to see some outputs. Yes, and we're seeing some outputs on the virtual terminal as well. So thank you, and that is all.
Hello, Assalamu alaikum. This is Nazmul Islam from Noobbus, and I will be giving a demo how our sensors are working. So let's try to run it first. Okay, so let's talk about the temperature and humidity sensor. So this is our humidity part and this is our temperature part, and if we just decrease or increase it, it will be shown in live view part. Okay, then let's talk about the water level sensing part. So as we can see, the tank level is 27%, which is not sufficient, and that's why our tank pump is still on. So if we just try to increase the value according to the code, if our tank level is more than 65%, it will be turned off. So okay, now we can see that the tank pump is off, and it is also shown in the LCD. Okay, now the soil moist content is 29%, and according to the code, if our soil moisture content is more than 50%, the water pump will not provide any water to the plants or trees. So let's see if it works. Okay, so as we can see, as our tank level is 79%, which is obviously more than 65%, our tank pump is off, and also our moist content is more than 50%, and that's why our water pump status is also off. That means our project is working. Thank you, and the rest will be continued by my other teammates.
Assalamu alaikum. My name is SM Motasim Billah Fahim. So I have designed the block diagram of this project. So after designing the front panel of this project, initially we got this temperature, humidity, tank level and soil moisture. Then we enclosed it with this while loop. Then we got the visa resource by which we will select the comport. Then we got the functions here, which include the clear function, open function, and the 6 read function by which we will read the strings. Then we got this flash buffer, and lastly we got the clear and the error control function. Then we got this 4 string to number converter, and here we got the time delay of 500 millisecond. Then here it is the array. So the first two input of this array is the time and date, which we will get from this get time and date function. Then the rest of the input of this array is temperature, humidity, tank level and soil moisture. And lastly here we got the table control. So this was all from this block diagram of this project. Thank you.
Assalamu alaikum. I am Shobhan Mondol. My previous teammates already discussed about the Proteus part and the LabVIEW block diagram part. Now I will discuss about the LabVIEW front panel and how we join Proteus with LabVIEW. So by using this virtual serial port tool, we join COM1 and COM2 virtual port, and with the help of these two ports, we join Proteus with our LabVIEW. So in our Proteus, in the serial port, we just add a physical port, that name is COM2, and set the baud rate 9600. And after that, in our LabVIEW, we select a port COM1, and by selecting this, the Proteus and the LabVIEW are now connected. So let's run the project. So after running the project, we see our virtual terminal, and here's some output. Let's run the LabVIEW part. So after running this, from this input, the LabVIEW is collecting data from our Proteus virtual terminal, and in this virtual terminal, what is showing is also sent to this input, and from this input in the array, it will be sent in our front panel table. So here you can see the data. The moisture is now 17, and the water pump is on and the tank pump is off. Also the temperature and humidity is showing, and here is the tank level, here is the soil moisture. So if we increase the soil moisture level, you can see the water pump is off, and you can see in our LabVIEW our water pump is off. And if we change the water level of our tank, the tank pump will on. In LabVIEW, you can see the tank pump is now on and the water pump is now off. If we change the soil moisture again, you can see the both of the pump are now on, and in our LabVIEW, you can see the both of the pump now on. So our Proteus is successfully connected with our LabVIEW, and it is sending data and showing data in LabVIEW perfectly. That's all from our side. Thank you, sir. Assalamu alaikum.